So let's take a look at a problem such as this. What if we have 1/3 and we're adding to that 1/2? All right, so the first thing we do is we look and see, do we have a common denominator between these fractions? And of course we don't. We have a 2 and a 3. So now we go to the second part. We have to figure out how to make a common denominator between these fractions. But because 2 and 3 are not multiples of one another, we're not going to be able in this case just to transform one of the fractions. I mean, think about it. If I multiply this one by 2 over 2, I would get 4 on the bottom. If I multiply by 3 over 3, I would get a 6 on the bottom, and none of those match the denominator above. So I'm really unable to just work with one fraction and get it to match the denominator of the previous one like I was able to do in the last section. All right, so when you can't do that, and likewise, I can't multiply this by anything to give me a 2 on the bottom. That's just not going to happen. So whenever you can't just work with one fraction, then you have to work with both fractions in order to get a common denominator. So the bottom line is what you're wanting to do is multiply this fraction by something, top and bottom, to give me a number on the bottom, a denominator, and then also multiply this fraction by something to give me the same bottom number. Now in this case, I look at 2 and 3, and I know that 2 and 3 will both go into 6. I know that they will both go into 6. So what I'm going to do, and that's what you're typically looking for, what I'm then going to do is I'm going to transform this fraction by saying 1/3, and I'm going to transform this fraction also. And what I'm going to do here is I'm going to multiply this fraction by 2 over 2. Remember, I can multiply anything I want, top and bottom, as long as I do it to top and bottom. Here I will have 2, 6, because 1 times 2 is 2, 3 times 2 is 6. All right, and then if I take this guy, I'll have 1/2. If I'm trying to find a common denominator of 6, what do I have to multiply here? 2 times 3 on the bottom, and also times 3 on the top. This fraction, as long as I multiply top and bottom by the same number, I'm okay. So what I will have here is 3 times 1 is 3, 2 times 3 is 6. Now look what's happened. Now I do have a common denominator between both of these fractions. In this case, it's a 6. And so then I can finish the rest of the problem exactly in the same way that I've always done before. So let's go ahead and do that. We'll talk about some details here as we go along. Since we have a common denominator, we just keep it for the ride. 2 plus 3, we can add them together, giving us 5. 5/6. Now this is already fully simplified. We don't need to simplify it anymore because you can't divide top and bottom by anything to make it any simpler. So that's the answer. So notice what we had to do here, different from the previous problems. We still were trying to get to the point where the denominators were the same. That's all we're trying to do with fractions when we add them. But in the previous problems, we only had to manipulate one fraction to get here. Now we had to manipulate two fractions to get there. The way that we pick what to do is because we're looking at these two bottom numbers and we're saying, gee, what can I multiply 2 times to give me a denominator that will also allow me to multiply this by something to get the same thing? For instance, I wouldn't want to pick 10 for my common denominator. If I tried to pick 10 for the common denominator, I'd have 2 times 5 giving me 10, and then 10 would be my denominator over here. Well, there's nothing I can multiply 3 by that would also give me 10. 3 times 3 is 9, 3 times 4 is 12. I can't multiply 3 by anything to give me 10. So I would never try to pick 10 as a common denominator. I only am trying to pick things for a common denominator that both of these denominators can essentially divide into. That's what you're trying to do. And with practice, it gets very, very easy and very fast. So let's get that practice now. Let's go on to the next problem. What if we have 1/4 and we're adding to that 1/3? We do not have a common denominator, and there's no way that we're going to be able to manipulate just one of these fractions to give us a common denominator. So we look at 3 and 4, and we start thinking of denominators that both of these numbers can divide into, 3 and 4. You know, you're not going to pick something like 8. 4 definitely goes into 8, but 3 doesn't go into 8. You don't want to pick something like 10 because neither one of these numbers go into 10. So you end up eventually going up and up and up. You get to 12. 4 goes into 12, 3 also goes into 12, so that's good. So I'm going to pick 12. And by the way, the denominator you use doesn't really matter. As long as you're getting a common denominator among the two fractions and do it correctly and add and simplify, you'll always get the right answer. So if I'm trying to get a common denominator of 12, then what I'm going to do is I'm going to take this 1/4 and I'm going to multiply by 3 on top and bottom. And that's going to give me 1 times 3 is 3, 3 times 4 is 12. And for this one, it'll be 1/3. To make this common denominator also 12, I'm going to have to multiply this by 4, and I'll have to do it to top and bottom. 3 times 4, it gives me 12. 1 times 4 gives me 4. Notice all we have done is we've cleverly multiplied these fractions by numbers so that we got a 12 in both slots over here. Because it doesn't really matter what the denominator is as long as it's common between the two of them. So we add these fractions together. We keep the 12 on the bottom. 3 plus 4, we add the numerators to get 7. And then we check to see, is this simplified? 7/12 is already full simplified. We can't divide anything into top and bottom to make that any simpler. All right? So much like many skills in math, you really just need to practice it. Once you see enough problems, you'll start understanding how are we choosing our common denominators and how are we getting the answers that we're getting. So let's pick, for instance, another one, 3/7, and let's add to it 4/3. All right, we're going to add these guys together. Now, this is a 3 down here in the bottom, and this is a 7 up top. We want to get a common denominator. There's no way that we could just transform this fraction to have a 7 on the bottom, because 3 times nothing gives me 7. Also, I can't just work with this one because 7 times nothing at all will give me 3. So I have to work with both of them, and I have to pick a common denominator that I know 3 can go into and also 7 can go into. And I start thinking through my multiplication tables, and the only thing that 7 and 3 can both go into, or the lowest number I can think of, is 21. Because 7 times 3 is 21, right? So I shoot for a common denominator of 21. All right, and so what I do over here is I take the 4/3, and then I say, well, I'm going to multiply top and bottom by 7, and that's going to give me 7 times 4 on the top is 28, and 3 times 7 is going to give me 21 on the bottom. And then over here, I'm shooting for common denominator of 21, so I have 3/7, and on the top and bottom, I'm multiplying by 3 in both cases, because I'm trying to get to a denominator to match over here. 3 times 3 gives me 9, 7 times 3 gives me 21. So notice what's happened is I have now fractions so that I have the number 21 in the denominator of both. Right? And then I add these together because now they have a common denominator. The 21 stays on the bottom, and I add these guys, 28 plus 21. 28 plus 21. Or I should say 28 plus 9, actually. We're adding the numerators together. So what I'm going to get there is 37. 37. 37, 21. And you start looking and saying, can I simplify it? Can you simplify it? Well, you can't really divide and simplify too easily, but then you also realize that this is an improper fraction. So this is perfectly fine to leave like this, but I also can write it as an improper fraction. 37 divided by 21 only goes in one time, right, with a remainder of 16 over 21. So I'm just converting from an improper fraction to a mixed fraction. If that confuses you, go back to Mastering 5th Grade Math, and we do a lot of problems in converting improper to mixed. Basically what you're doing, you divide this, it can only go one whole time, and so 37 minus the 21 gives you 16, and you always put it over the same denominator. This is a skill going back and forth between these two things that we got from previous lessons. All right, so but again, notice, all we're doing is trying to manipulate these fractions to give me the same number on the bottom. Once that happens, we add and simplify the same as we always have. All right, let's do a couple more just to get a little more practice. What if we have 3/4 plus 3/5? 3/4 plus 3/5. All right, we're going to have to work with both of these fractions. We don't have a common denominator, and so how do we transform? Well, I'm thinking of 4 and 5. What is a number that 4 and 5 can both go into? I wouldn't want to pick 10 because 4 doesn't really go into 10 evenly. I wouldn't want to pick 15 because 4 doesn't go into 15 evenly. So I keep going up and eventually I hit 20. I know that 4 times 5 is 20. I know my multiplication tables. So I know that 20 is a number that both of these can go into. So I'm going to pick that. So then I say 3/4. And I say, well, if I'm shooting for 20 on the bottom, I'm going to multiply this by 5 and the top by 5. So what I'll have on the top is 15. 3 times 5 is 15 over 20, like this. And if I'm shooting for 20 over here, I'll have 3/5, and I'll multiply top and bottom by 4, like this. And so what I'll end up having is 3 times 4 is 12, and then over here 5 times 4 is 20 on the bottom. So now I have two fractions, both with the number 20 in the denominator. So because I have a common denominator, I keep it and I add the tops. Now if I add those together, I'll have 20, and then the 5 plus 2 gives me a 7. I'll have 27. So the answer is 27 over 20. Now, I can't simplify this in terms of in terms of lowest terms any more than it already is, but I also notice that it's improper. And I can leave it like improper if I'd like, but I can also choose to convert it to a mixed number. 27 divided by 20 can only go in one time with 7 left over out of 20. And you always put the 20 because you have to match this denominator. So it goes one time, so 27 minus 20 gives me the 7, the 20 goes there. So I can circle either one of these guys is really both the correct answer. You basically just have to think about if it's improper or not in your final answer. All right, we'll just do a couple more for additional practice. What if I have 1/3 plus 5/8? Right? I've got to think of a common denominator that I can use. You know, I wouldn't pick something like 16. I mean, 8 goes into 16, that's great, but 3 does not go into 16. I wouldn't use something like 10 because 8 doesn't really go into 10 and 3 doesn't really go into 10. So I start marching up numbers and I start getting used to the idea that I'm looking for a common number that both of those can divide into, and eventually I hit 24 because I know that 8 times 3 is 24. All right, and so then what I end up having is I transform this guy, 5/8. What I end up doing is I multiply the bottom by 3 and also the top by 3 because I'm trying to get to 24 in the bottom. 5 times 3 is 15 24ths. And then on the top, what's going to happen is the same sort of thing. I'm starting with 1/3 and I'm trying to transform it. And so I'm multiplying by 8 over 8. Again, same number top and bottom. It's totally okay to do as long as I do it to both. On the bottom, I will get 24. On the top, I will get 8. Now I have two fractions, both with the same common denominator. So I add them together. I get a 24 in the bottom, I just retain it, and I add this guy. 15 plus 8 is 23. And I have 23 out of 24 slices of pizza. I cannot simplify that any further. It's not improper, and that's the final answer, 23 out of 24. All right, now let's do the very last problem here. We have the fraction 2/4, and we're adding it to 1/3. All right, so I look at this again, and I'm like, what common denominator can I get between 4 and 3? As you get more practice, you'll get pretty good at identifying what a common denominator could be for those. Immediately, I jump on the number 12, because I know that 4 can go into 12, and I know that 3 can also go into 12. So it's a suitable common denominator when that happens. So for the top one, I have 2/4. What would I need to multiply to give me 12 on the bottom? Well, I'll multiply by 3 over 3, and that gives me 6 over 12 because of the multiplication going on there. Then, over here I have 1/3. What would I have to multiply here? I have to multiply by 4 on the top and also the bottom because I'm trying to reach a 12 for the common denominator. 1 times 4 is 4, 3 times 4 is 12, just like that. So now I have two fractions with the same exact common denominator, which is exactly what I wanted. So I add these guys together. Because the denominator is 12, it stays for the ride. 6 plus 4 is 10. So the answer is 10/12. Now that's exactly correct, totally right. I could circle that. But then I notice this is not in lowest terms because I can divide the top by 2, and I can also divide the bottom by 2. They're both even numbers, basically. So 10 divided by 2 is 5, and 12 divided by 2 is 6. So I get the fraction 5/6. That is the final answer. So